Projecting class diagram or UML from SBC process algebra. I'm Dr. William S. Chow. Chapter 1 SBC process algebra is the meta model or UML. SBC process algebra is used to ensure consistency between all these UML different diagrams. Because SBC process algebra is the meta model or UML, so class diagram can be projected from SBC process algebra. Therefore, we would say class diagram is a projected view of the SBC process of a system. Chapter 2 discusses what is SBC process algebra. SBC stands for Structural Behavior Correlations. SBC process algebra really is able to integrate the system structure and system behavior of a system. SBC process algebra is a formal language. Therefore, we need to talk about its lexical part and syntactical part, also the semantical part. First, SBC process algebra has many entities as its lexical part, such as operational code or operational return formulas, and the operational name and the parameter list, such and such. An operational formula you use to complete, describe an operation. There are two kinds of interaction in SBC process algebra. Type 1 interaction is a kind of interaction between the outside actor and the COE object. Type 2 interaction describes the interaction between an caller object and the COE object. SBC process algebra uses 3 BNF rules to describe the syntax of its language. With the syntax of SBC process algebra, a system is then modeled as from 1 to n IFD, and each IFD is represented by G11, dot, A12, dot, A13, dot, and dot, and stop expression with many other IFDs. SBC process algebra uses the transitional rule to describe the semantics of the language. There are 2 transition rules, such as prefix and the summation rules. With the transition rule, we then get a transition graph of a system. A transition graph is described by the transition relations T with 3 attributes. And we further extend this transition relation T as 6 attributes. Now, let's have the summary of SBC process algebra. The transition graph is a single and only one diagram that SBC process algebra used to describe the whole semantics of a system. Now, let's go to the last chapter. Chapter 3 describes how to project a system's class diagram from SBC process algebra. We say a system's transition graph is described by the transition relation T with 6 attributes. A class diagram in UML describes all the classes of a system. Also, for each class, it will describe all its operational code signature. A class diagram is described by a relation class T with 2 attributes. The L attribute is the operational call signature. The second attribute is the COE object or COE component. Now, let's see the projection algorithm. There are 3 steps. The first step is to select 2 attributes from the T relation into a new class D relation. The second step is to select 2 attributes from the T relation into the class D return relation. The third step is we update the class D relation by merging operational call formula and operational return formula if there exists any operational return formula in class D return relation. Thank you for your listening. Bye-bye.